So here we have the finished model. This is the model we did first with the multiple modifiers. The model that we tried second with the lattice did not work. That had holes in the nodal points, as we suspected, and so it wasn't a watertight structure that could be printed by the 3D printer. There is a program which the Fab Lab could have run over it to close those gaps, but it's a very expensive program that would have also taken a bit more time. So this approach definitely is the better one with the multiple modifiers. It's worked very well in terms of the larger holes, and certainly the holes in the middle, the big hole in the middle, but the smaller holes have closed up, and that's because they're under 2 mils, and they're quite a lot under 2 mils. But basically every gap or hole should be at least 2 mils, otherwise the glue and which closes over the resin will close that hole. The other thing to note is that the material needs to be at least 1 mil to be printed as well. So we've done pretty well on that side of things. But for future references, 1 mil for the actual material and 2 mils for the gaps. In terms of the curvature, it's worked quite nicely. Overall, because this is the cost is based on the weight of the material, this cost $20 for an object which is 8 centimeters tall by 2.5 centimeters wide, but obviously a big hole in the middle. So if you're doing any shapes in 3D, just make sure that you hollow out the middle and you'll save a lot of money. So I think this has been a useful experiment. We have a definite method which can be used to create a physical model out of 3ds Max, and we can do that relatively cheaply with the multiple modifier technique. So thanks for listening.